In this example, two ships are leaving a harbor at the same time. Now, I'm not sure if you'd ever really have to do this in real life, but this is kind of a problem that comes up a lot. So be prepared for this. And the goal of this problem is just to try to get you to use your trigonometry in a quasi-real life situation. But anyway, we'll keep going with this. The angle between them is 36.3 degrees. Assuming they continue in a straight line, so they're not zigzagging or anything like that, we want to find the distance the two boats are from each other if the first boat is 22.3 nautical miles away from the harbor, and the second boat is 15.6 nautical miles away from the harbor. Wow, a little wordy. We're going to read through it again, but let's try to set up this and think about it. You know, actually think about two boats leaving this harbor and think about the angle that they're going apart. So the angle between them is 36.3, so we got to have a harbor. We'll make that our harbor right here. And then one boat's kind of going like, you know, over that direction, and the other one might be going, you know, this direction. And I think the one boat goes a little bit further than the other one, so if you wanted to try to make it a little bit, with precision, you can. This angle is 36.3 degrees. And the distance that we want to find the distance between this, so we're looking for this distance here. So we'll do distance and a D for distance, and we know that the first one's 22.3 nautical miles away, and the other one is 15.6 nautical miles. Alright, well, there's a few different ways that you can tackle this one, but I think probably the easiest one, because we have two sides and an included angle and we're trying to find this side length over here, is to use the law of cosines. So with this one, we would need to have, if to use the law of sines, we would need to have this opposite angle. And with this one, we would need to have this opposite angle, and with this one we have the angle but not the side, so it's going to be problematic for us to set up the law of sines. Also, although this kind of looks like a right angle, we don't know if it is a right angle or not, so we don't want to set up our regular trig ratios. We're not sure if that's a perpendicular. If we use the law of cosines, we've got d squared is equal to each of the other sides squared and added together. And we know we're in nautical miles here, so that'll be our unit. Minus 2 times each one of those. And then we'll multiply that by the cosine of 36.3 degrees. Remember, it's the law of cosines, so we're going to use cosine there. So I think this is probably going to be easiest just to type this sucker in and see what happens. We got 15.6 squared minus 2 times 22.3 times 15.6 times the cosine of 36.3. Just check real quick, make sure you're in degree mode. We are, cool. Hit enter, and we've got 179.9 miles. So we got D being 179.9 nautical miles. Now, when I saw that, it kind of looked a little big. Like, this is only 36.3 degrees. And, oh boy, I mean, this is only 22.3 miles, and this is 15.6, so that's looking pretty unrealistic. I kind of did this on purpose, but this is a mistake that many students do, is they'll type in this whole thing, hit enter, and just write it down without ever actually thinking about it. This is not a reasonable answer. It's way too big. The one thing that we forgot here is this is d squared, so we need to take the square root of that answer. And that's 13.4, or about 13.4, should be about here. 13.4 nautical miles. That's way more believable. If this was a right angle and that was 30 degrees, then this would be 11. Just 1/2 of the hypotenuse. So we're guessing it's probably somewhere in between 10 and 20. This is way outside of our league, and this is much closer right here. So now we have an appropriate answer. We've got our units. Looks like we've done everything correctly. Feel pretty confident that these boats are 13.4 nautical miles approximately apart from each other.